Hello everyone, I hope you're all well. This is Rashid Khan and you're watching my YouTube channel. In this video, we'll go over the main concepts from the topic called static electricity. In this topic, you will need to know about three things. The first one is charging objects. Second one is electric field around a charged object. And the third one is uses and dangers of static electricity. Let us have a look at the section called charging objects. Now, when it comes to objects, there are two types of objects. One are called insulators, and the other type are called conductors. Within insulators, I'll say electrons can't move around. When it comes to conductors, here electrons can move around. Insulators are charged by friction, whereas conductors are charged by method called induction. When it comes to conductors, we can think about both metal objects or trees. When it comes to insulators, I can say here like balloon, glass rod, and even plastic rod. These are all examples of insulators. You have to remember, when you are charging insulators, this will be due to removal or addition of electron. This is the most common mistake that students make on this topic. They start talking about positive charge. So you will never ever talk about positive charge. It will always be either addition of electron, which is negative charge, or removal of negative charge. We can say if electron is added, then the object will become negatively charged. This will be our outcome. If electron is removed, then our outcome will be positively charged object. Now let's consider the side with conductors. When it comes to conductors, we have to talk about induction. So first, let's understand what induction is. So what happens in induction is, if I have, this is my conductor. So if I bring a charged rod next to it or charged object, let's say this charged object has negative charge on it, what it will do is it will repel electrons in this conductor, and all electrons will then get accumulated on the right side. The left side will get short of electrons in this case, and therefore it will now accumulate positive charge. And we know opposite charges attract. Number one, while like charges repel. Whenever induction will take place, it will always result in attractive force. Always produces attractive force between objects. This is all you need to know on the section called charging objects. So remember, there are two types of objects, insulators and conductors. You must know the difference between them two. Why is this one called insulator? Because electrons can't move around, but in case of conductors, electrons can move around. Insulators are always charged by friction, whereas conductors are always charged by a method called induction. Now, when friction will take place between two objects, if electron is added to an object, then the outcome will be the object will become negatively charged. If electron has been removed from an object, then the outcome will be positively charged object. When it comes to the conductors, we have to look what induction is. Whenever we have to perform induction, we will have to consider conductors. So you'll have to bring a charged rod close to a conductor. When you bring it close to a conductor, it will repel or attract electrons depending on the type of charge that this object has. In my case, it has a negative charge. What it will do is it will repel all electrons in this conductor towards the right side. So the right side will become negatively charged because this will have now surplus amount of electrons. Whereas the left side is short of electrons now, so it will obtain positive charge. Then you have to remember one thing, opposite charges always attract, like charges always repel. Between them two sides, there will be a force that will be attractive in nature. The next section that we need to know about is the electric field around a charged object. Now, before we start working on this, we have to understand what do we mean by word electric field. So electric field is the region around a charged object where test charge will experience a force. Now you need to remember this test charge, it is always positive. So in your exam, you will be asked about the direction of electric field. So you'll have to make sure you apply this concept. I'll show you in a minute how to use it to figure out the direction of electric field. So when it comes to this force could be weak or it could be strong force. In terms of its direction, it could be attractive or repulsive force. When it comes to the charged objects, there are different types of objects that you need to consider. It could be point charge. It could be an object. So when I say point charge, this means it could be a negative point charge and could be a positive point charge. Comes to object, here we are talking about objects like rod. We can say this is rod and this is my balloon. These are examples of objects. So let's quickly have a look. How would we draw electric field around a charged object? Let us consider the field around different types of charges. So in the first case, I've got 2 point charges, a positive point charge and a negative point charge. So what I'll do is, like I said on the previous page here, I said my test charge is always positive. So what I'm going to do is I'm going to bring a positive charge. Now I know in this case, if I bring a positive charge, they both will repel. So in this case, I can say the force will be pointing away from this. If I bring a positive test charge, it will be repelled. In this case, again, I'll do the same thing. I'll bring a positive test charge, and I know this time they both will attract because opposite charges always attract. So in this case, my direction will be towards the center. Once I have determined the direction of the electric field around my charges, now I can think about this section. Is it going to be weak force or is it going to be strong force? The density of the field lines will determine the force experienced by the positive test charge. So I can say in this case, this is my positive test charge, this is my positive test charge. So this is our test charge. Here, this is my test charge. In this case, I will say it will experience repelling force, and number 2, it will be weak force. I'm making comparison of them two. So compared to this one, it will be weak force. Why is it weak force? The amount of these lines around the charge will determine the strength of force. In this case, I've got loads of lines around it. So this time it will experience stronger force. This time I'll say the test charge will experience one, we can say strong force. And this time it will be attractive. In the second case, I've got something which is a little bit different. I've got 2 parallel plates. So if I have two parallel plates and they have opposite charges, then again, to determine the direction of the field, what I'll do is I'll bring a positive test charge. So if I bring a positive test charge here, here, and here, what will happen in this case is, again, it will get repelled from here, here it will get attracted, here it will get repelled. So I can say my direction will be downwards. It will be downwards. So I can now say for this positive charge, it will be, number one, I can say it will move downwards. Number two, now in this case, if you look at the distance between any two lines, it always remains same. And this is what we call uniform electric field. So I'm now going to say I've got three locations, location 1, location 2, location 3. So I'm going to say the force experienced by test charge is independent of its location. That's very, very important. So no matter where you put the test charge, it will always experience the same amount of force. This is all you need to know about electric fields on your specification. So remember one thing, it is always the force experienced by the test charge that will determine the direction of the electric field. The amount of lines around the charge will determine the strength of electric field. If there are more lines, then the force will be stronger. If there are less lines, then the force will be weaker. If you have two parallel plates, then the field will be uniform. And if it is uniform, then the force experienced by the test charge will always be independent of its location. The last section that we need to know on this topic is dangers and uses of static electricity. So let's first consider dangers. So to understand dangers, we'll go through this section again. I've got two parallel plates. The top one has a positive charge, the bottom one has a negative charge. So my electric field will be from top to bottom. So if a charged object comes in between, or I can say if charges come in between these two plates, they will move upward, they can move downward depending on their polarity. Now, due to these two charges, there will be a potential difference that will exist between these two plates. Now, there are two options available to us here. If this potential difference, the difference between them two charges gets very, very large, and this is something that happens in terms of cloud and earth. If it gets very large, then spark/lightning will take place because electrons will flow. The other option is if these two plates come in contact with each other, then they will discharge each other as well. They'll become neutral. And if that happens, spark will be produced. For example, when you're walking on a carpet, you will rub your shoes against the carpet and your shoes are made of insulating material. They will accumulate charge. So your body will become charged. And then if you go and touch a conductor, then electrons can move to your body or from your body to the conductor, and there will be spark that will be produced. That's what can cause a lot of problems, especially, for example, let's say when we are refueling an aircraft. We will look at these dangers in more detail when we answer exam questions. Whether it's dangers or uses, it will always have two objects. One will be charged object, plus you will have a conductor. So when it comes to the uses, again, we will have charged object plus conductor. And we know whenever you have these two things, then the conductor will become charged by induction. It will get charged by induction. So I can say if object is positively charged, then the conductor will gain negative charge. If the object is negatively charged, then the conductor will gain positive charge. And we know once you have opposite charges, then they will always attract each other. This is useful in applications such as number 1, painting conductors, number 2, uh, spraying crops. Now remember, like I said earlier, trees are classed as conductor, so these crops will be classed as conductor. When it comes to the dangers and uses, you need to remember one thing, and that is there will always be two objects involved, charged object and a conductor. When charged object and conductor will come in contact with each other, what will then happen is spark will be produced. To avoid that spark being produced, what we do is we will neutralize this charged object by using an earth wire. So the note here I can say is to neutralize charged object, we will use earth wire. So before refueling the aircraft, what do? We attach an earth wire which is coming from the ground. We attach it on the aircraft so that it never gets charged. So this is all you need to know on the section called dangers and uses. We will go in more detail on this topic once we start working on exam questions. So have a look at the next video and you will find many answers to the questions related to situations where we are making use of static electricity and are avoiding dangers caused by the static electricity. That's it for now. I wish you all very good luck with your exam preparation. Thank you.